Ever heard of a company called DeepSeek?
Yeah, I think so.
Well, they've been making some serious waves in the AI world,
Oh, yeah. What have they been up to?
open sourcing some incredible tools
Interesting.
for optimizing large language models.
Ah, okay. I see LLMs. Cool.
Yeah, so think of it like this. They've figured out a way to make training LLMs way more efficient.
Like, how do you do that? That sounds pretty tough.
It is. It's like,
Yeah.
imagine training one of these models is like running a marathon.
Right.
DeepSeek's found a way to make that marathon faster, cheaper, and with way less effort.
Makes sense, yeah.
So less burnout, more sustainability.
Oh, that's a really good point.
And they're sharing these secrets with everyone.
Really?
Yeah.
Open source, huh? That's pretty huge.
Yeah, it's a game changer, especially for researchers and developers who don't have the resources of, like, a Google or a Microsoft.
Definitely. Opens up a lot of doors.
All right,
But-
so let's jump into the first tool they've released, DualPipe.
Okay. DualPipe.
It's, well, they call it a bi-directional pipelining algorithm.
Hmm.
But let me give you an analogy.
Okay, yeah.
Think of a two-lane highway.
Okay.
One lane is for calculations, the other's for data transfer.
Right. I'm following.
DualPipe is like a traffic management system that makes sure both lanes are always flowing smoothly.
So there's never, like, any traffic jams or anything?
Exactly. No bottlenecks or wasted time.
That makes sense. But why is that so important for training LLM specifically?
Well, training these models involves dealing with an insane amount of data.
Right, I can imagine.
So even tiny improvements in efficiency can save a ton of time and resources.
Oh, yeah, for sure. With all that data. It's got to be huge.
And DeepSeek's even shared a visualization of how DualPipe works.
Really?
It's in their report, and it honestly looks like a perfectly choreographed dance between the calculations and the data transfer.
All right, so they're, what, like eliminating all those pauses and hiccups you get with traditional pipelines?
Yeah, those pipeline bubbles, they call
Oh.
them. It's like they've figured out how to get rid of all the wasted time.
That's pretty cool. So faster training times, but without sacrificing performance.
Exactly. And they've got the data to back it up.
Impressive. So what's the second tool they've released?
All right, so this one's called EPLB, the Expert Parallel Load Balancer.
EPLB, huh? Sounds complex.
It is, but think of it like a super smart traffic cop.
Okay.
But instead of directing cars, it's making sure no single expert in the model gets overloaded with work.
Experts. What do you mean by that?
So an LLM is made up of all these different modules, right?
Right.
And each one kind of specializes in a different task, like different parts of language processing.
I see.
Those are the experts. And EPLB makes sure the workload is balanced between them.
I see. Makes sense. So how does it actually do that?
Well, they have this thing called the redundant experts strategy.
Redundant experts.
Yeah, it's kind of like having backup singers ready to step in if the lead vocalist gets tired.
Okay.
EPLB does the same thing for the model components. Make sure there's always enough processing power to go around.
Ah, that's clever.
And the best part, they didn't just share the theory behind EPLB.
No. What else did they share?
They open sourced the actual code.
Seriously?
Yeah. So anyone can take it, study it, implement it, even build on top of it.
Wow. That's a game changer for sure. Makes it way more accessible for people to, like, actually use it.
And this all ties back to that idea of sustainability we talked about earlier, right? Less wasted computing power means less energy consumption.
Oh, for sure. Absolutely. It's not just about speed and efficiency. It's about making AI development more responsible, too.
Exactly. And we haven't even talked about the performance profiling data they've released.
Oh, yeah. Tell me more about that.
Well, it's like getting a behind-the-scenes look at how these tools actually perform in practice.
Oh, wow. That's got to be interesting. Lots to dig into there.
Yeah, it's pretty fascinating.
So it sounds like DeepSeek's really making an impact with all this open source work.
They really are. It's like they're pushing the entire field of AI forward, making it more accessible and more sustainable.
And who knows what kind of cool new applications and breakthroughs will come from that.
Exactly. And that's what makes it so exciting.
Yeah, I can't wait to see what people do with these tools.
Me too.
So where do we go from here? Should we take a closer look at how DualPipe actually works?
Yeah, let's do it.
Okay, let's dive in.
So DualPipe, we were talking about this being a two-way street.
Right, a bi-directional pipeline.
Okay, yeah, that. But how does that actually make things faster?
Well, imagine a traditional pipeline is like an assembly line, okay?
Okay.
You have one step that has to happen before the next one can start.
Right.
With DualPipe, you can have multiple steps happening at the same time because data is flowing back and forth.
So less waiting around.
Exactly. It's all about overlapping the different stages of computation and communication.
So no more pipeline bubbles, like we talked about before.
Nope, no more bubbles. Everything keeps moving.
And this scheduling scheme they've come up with, that's what makes it all work.
Yeah, it's pretty clever. They divide the data into these smaller chunks, micro batches.
Micro batches.
And the algorithm figures out the perfect timing for moving those chunks through the pipeline.
Like a conductor leading an orchestra?
Kinda, yeah. It's all about keeping everything in sync.
I bet it looked pretty cool, that visualization they shared.
It does. It's almost like a dance or something.
And they're seeing like a 50% reduction in training time with this.
Yeah, their benchmarks are pretty impressive.
That's huge. Okay, so we got a faster pipeline. Now what about EPLB, this load balancer?
Right. So this one's all about making sure no single part of the model gets overwhelmed.
We were talking about the redundant experts thing.
Yeah, so remember how we were saying that an LLM is like a team of specialists?
Right, the experts.
Well, sometimes one expert might get way more work than the others.
Like that one person in the group project who ends up doing everything.
Aha, exactly.
So EPLB steps in and makes sure everyone's sharing the workload evenly.
Right. And it does that by creating copies of the busiest experts.
Copies, like clones.
Kind of. It replicates the experts that are getting slammed.
And then it spreads those copies out across all the available processing power.
Exactly. It's a really smart way to prevent bottlenecks.
We keep talking about this algorithm EPLB uses, this heuristic thing.
Oh, right. So a heuristic algorithm is basically like a set of rules of thumb.
Rules of thumb.
Yeah, it helps EPLB make quick decisions without having to overthink things.
Okay.
So it's not always going to find the absolute best solution, but it's going to find a good solution really fast.
Makes sense. Efficient.
Exactly. And they actually have two different load balancing strategies they use.
Oh, yeah. Tell me more about that.
So they've got hierarchical load balancing
Hierarchical.
and then global load balancing.
Okay, two flavors.
Yeah. So hierarchical load balancing works best when things are kind of neatly organized.
Neatly organized how?
Like if the number of servers you have matches up perfectly with the number of expert groups.
Oh.
And then it tries to keep related experts together on the same server.
So they can chat more easily.
Yeah, exactly. It reduces the amount of communication that needs to happen between them.
Makes sense. Less overhead.
Right. But sometimes things aren't that neat and tidy.
And that's where global load balancing comes in.
Exactly. Global load balancing doesn't care about those groupings.
It's just like put the experts wherever there's space.
Pretty much. It's all about spreading the workload out as evenly as possible across all the available resources.
Okay, that makes sense. So you've got these two strategies, and EPLB just figures out which one to use on the fly.
Yep. It's pretty adaptable. It analyzes the situation and picks the best approach.
Smart. So we've got a faster pipeline, a smarter load balancer, and we're using less energy in the process.
Yeah, it's a win-win-win situation.
And it's all thanks to DeepSeek's commitment to open source.
Absolutely. They're really pushing the boundaries of what's possible with AI, and they're making sure everyone can benefit from it.
It's pretty inspiring, honestly. They're not just making better AI, they're making AI better for everyone.
Couldn't have said it better myself.
Okay, so we've talked a lot about DualPipe, EPLB, all these technical details.
Yeah, it's been quite a deep dive.
But there's one more thing I wanted to touch on. The performance profiling data that DeepSeek released.
Right. It's like they're giving us a backstage pass to their whole process.
Exactly. So what can we actually learn from this data?
Well, it's super detailed. Like, they've documented everything.
Like what kind of stuff?
Training times, how much they're using their resources, energy consumption, all of it.
So it's not just about proving that their tools work. It's about understanding how they work in different situations.
Yeah, exactly. They tested these tools with all kinds of different setups, different model sizes, different hardware.
Oh, wow. So we can actually see how performance changes depending on all these factors.
Exactly. It's super valuable for, like, anyone who wants to really understand how this stuff works.
And they even give you instructions on how to visualize all this data, right?
Yeah. They show you how to use some free tools, like stuff built right into your web browser.
So anyone can basically do their own analysis.
Pretty much. It's the beauty of open source. It makes all this knowledge accessible to everyone.
Okay, so zooming out a bit here, what does all this mean for AI as a whole? Like, what are the bigger implications?
Well, for one thing, I think it's going to make AI development way more accessible. I mean, they're basically giving away these incredibly powerful tools.
So anyone can build state-of-the-art models, even if you don't have a Google-sized budget.
Right. It levels the playing field.
Mm.
And that could lead to a ton of new innovation.
More people working on AI, more ideas, more breakthroughs.
Exactly. And it's not just about making things faster and cheaper either.
We've talked about the sustainability angle.
Yeah, but there's also this ethical dimension, you
Yeah.
know, making sure AI benefits everyone, not just a select few.
Because if these tools are accessible to more people, that means the power of AI is also more distributed.
Exactly. And that's a good thing, right?
Absolutely. So it sounds like DeepSeek is really changing the game here.
They really are. It's inspiring to see a company so committed to open source and to making AI better for the world.
Yeah, it's pretty amazing. And it makes you wonder what's next, right? What other breakthroughs are just around the corner?
I don't know, but I'm excited to find out.
Me too. Well, I think that wraps up our deep dive into DeepSeek and their incredible work on LLM optimization.
Yeah, great discussion. Lots to think about.
Absolutely. And to our listener, thanks for joining us. We hope this has sparked your own curiosity about the future of AI. We'll see you next time for another deep dive into the world of cutting-edge research.